Here's a really interesting kinematics question, which has nothing to do with acceleration, has nothing to do with, derivatives or integrals or any complicated mathematical or any complicated maths or calculus or anything like that. Instead, there's only one formula that will be applied, which is velocity is distance over time. So it's the kind of motion which is called rectilinear and uniform. Okay, in other words, this is a motion which is defined by the fact that the velocity vector of our particle or particles is constant. Okay, but we're not going to use vectors or anything like that to solve this. And this is also the kind of question which most students, they know that this is the only formula they need to apply, but the question is so not necessarily roundabout, but not as straightforward as they would expect, that they don't even know where to start. So before we even get to use the formula that velocity is distance over time, we have to use a bit of thinking and try to interpret what is going on. So let's read the question. Let's try to understand the situation that we're looking at by drawing a diagram, which is very important, by the way, and then we'll see what we can do to solve it. So a group of athletes are running in a single line of length L with the same speed V. Okay, so we have a couple of athletes. I'll draw a few of them like this, and they're all running with the same speed, obviously, because if they don't have the same speed, their distances between them would change. So they're running in a straight line, okay, with the speed V. Their coach is running with the speed of U towards the line of athletes. So let's say the coach is I'm not going to draw the coach on the same line, but I'm going to draw the coach somewhere here like this. And the coach is running towards the line of athletes with a speed of u, which is less than v, okay? And then when each athlete encounters their coach, they start running backwards with the same speed v. So, in other words, the speed of the athletes, it doesn't change at any point, it just changes direction. So what essentially happens is the when the coach gets to this point like this, he keeps running, so nothing happens to the coach, so the coach just keeps running their own way, and then this athlete will start traveling backwards with the same speed. But what I should actually make a bit obvious is that when so when the athletes start running backwards, they're not going to collide with the other athletes behind them. So maybe they're going to be a bit to a side like this, and they're going to start running backwards with a velocity which is the same as v. Okay. Yeah, and then now I just realized the question doesn't actually make it clear that u is less than v, but it should. So this is one thing that should be in the question, which is u being less than v. Okay, just assume that's the case, but I think this question forgot to mention it, but it's a true statement. Okay, so let's think what happens as this keeps going. Okay, because the question is asking us what is the length of the single line when all the athletes have turned back. So if the initial length of this file is L, okay, and it can be bigger than that, then what is the length of this file when all the athletes have turned around? Okay, so let's draw the diagram again, but this time I'll just draw two athletes. So those are two athletes that are running, and the distance between them, well, I can't really call it L because it's not, the L is the length of the whole file or line of athletes. So let's call this delta L. Okay, and then we know that they're both running with a speed which is v, and then this guy, the coach, starts running towards them, a bit offset, of course, like this, with a smaller speed, which is just u. When they meet, the coach is, say, somewhere here, and the coach travels still with the same speed of u, and then we have the first athlete that met the coach. his velocity is going to change and it's going to be pointing backwards. So it's going to have velocity v. Now the other athlete, I'm going to draw the other athlete maybe something like, well, let's draw it here. Okay. They don't have to be offset, but I'm just offsetting them to illustrate or to be able to easily draw the distances and the velocities and so on. So at this point, the distance between the two athletes is delta L, because this is the moment that the front athlete just turned around, so nothing changed in terms of the distance. Now this other athlete, he is traveling with a velocity of v. Okay, so let me just take this and move it to the next page, and then let's try to think what happens when, let's call this number 1, 2, and this is the coach. So 1 and C, they just met. So now 1 is running backwards with a speed of v, and now 2 and the coach are going to meet as well. So they're going to meet at some point, let's say maybe here. So this is going to be the second athlete, this is going to be 2. The coach is going to be somewhere here. So he's going to travel a certain amount of distance from here to here, basically. Okay, so the coach has speed of u, and now in this moment, now this other athlete is traveling, he starts traveling backwards with the same speed. Okay, now at this point, the first athlete is somewhere behind, well, is somewhere here. We don't know exactly where, but let's draw the first athlete here. So he keeps running with a speed of v. Okay. So this is actually what's happening, and what we have to find, if you think about it for a second. So this is the initial distance between the athletes, the delta L. So now the distance, the new distance between the two athletes is this one, which we call delta L. So we somehow have to find an expression for delta L prime, I mean, in terms of things that we know, which is delta L, u, v, and so on. Okay, so let's see how we can perhaps do this. Okay, we have this 1 and okay. So let's first try to find the time that it takes 2 and C to meet. So 2 and C, they meet up after how long? Okay, so how long does it take for the coach who's running towards athlete 2 and for 2 who runs towards the coach to meet up? So they're going to meet up along this line, right? So they're going to meet up at this point here, essentially, which is on this line. So what we can then do is we can find the distance from 2 to this line, which is, let's call this x1. And we know x1 is equal to velocity of this guy times the time. So that's the time it takes for 2 to reach basically this point. And then this other distance here, this is a distance run by the coach. So this is x2. So we have x2 is equal to u times t. And you can probably see by now that x1 plus x2 is delta L. So delta L is v plus u multiplied by delta t. Okay, so this is one thing we found out, which is the fact that delta L is v plus u delta t, or if you want the time, which is delta t, of course, that's delta L over v plus u. So that's the time it takes for the second athlete to encounter the coach from the moment that the first athlete was just turned backwards. Okay, so this is the time that that represents basically. Okay, so the other thing to do now is to somehow find some kind of expression for delta L prime. This distance delta L is given, or can also be given, as the difference of two other distances. So if you think about it for a second, this is what we can write. We can write that this delta L is the difference between this distance, which let's call it Z1. So this is the distance ran by the first athlete from the moment he encountered the coach up to the moment the second athlete encountered the coach. Okay, so in other words, the time taken for the first athlete to run a distance Z1 is this time here, delta t. Okay, because those two scenarios, they're both separated by an amount of time which is delta t. So this is what happens at first, and then delta t seconds later were in this case. So everyone moved a certain distance and for an amount of time which is delta t. In addition to that, we also know that this distance here, we just called it x2 earlier. Okay, so delta L prime, which is what we're trying to find, is Z1 minus x2. So this is what we're going to use. So Z1 again is the distance ran by the first athlete from the moment he literally ran away from the coach, minus x2, which is, so x2 is the distance ran by the coach in this amount of time, delta t. Okay, so let's see what delta L prime becomes. So delta L prime is Z1 minus x2, which, so Z1 is the velocity of the first athlete, which is, of course, v times delta t, minus x2, and minus x2 is the distance run by the coach, which is u times delta t. So this is v minus u times delta t. And we actually know what delta t is. So delta t is delta L over v plus u, right? It's the thing we just found earlier, and this is it. So the answer is delta L v minus u over v plus u. Okay, now this is just for two athletes, okay? But if you think about it, the same thing applies no matter how many athletes you have, because the total distance of the total length of the line is just the sum of all those equal delta L's, okay? So, which is, let's call it n times delta L if there are n athletes, for example. And then the final length is gonna be delta L prime plus delta L prime plus and so on, which is the same number of athletes times the new length in between them, which is delta L prime. So what we can then do is we can take this equation here that we just found. So delta L prime is equal to delta L v minus u over v plus u. If we multiply everything by n, this is n delta L prime is equal to n delta L v minus u over v plus u. And of course, this is L prime. This is the length of the total of the entire line of athletes after they ran away from the coach. And this is the original length. So the final answer for this question is that the final length is L v minus u over v plus u. And as you can tell, this value is less than L. Okay, so the final length of the athletes after they encounter the coach is going to be less than their original length. And then you can try to, as an extra task, you can try to understand and try to figure out why that's the case. But that's the end of the question.